Welcome everyone, and thanks for joining us for this presentation showcasing the features of LandXplorer Studio. I'll be running through a high-level overview of creating, visualizing, and analyzing a digital city model, and showing you that you do not need to create 3D data from scratch, and you can leverage your investment in existing Autodesk software such as AutoCAD Map 3D, Topobase, 3D Studio Max, and Revit, as well as data from other enterprise systems. All this data can be combined into one evolving, dynamic model, providing decision makers and stakeholders with a representationally accurate model of the city. The first step in creating your model would be to load a terrain file. This can be done by either loading a pre-existing terrain or creating a new one from files such as digital elevation models or ASCII grids. This terrain will form the base of your model and can be used over and over again. Next, you would give the terrain a more realistic look by adding raster images as terrain textures. As with the terrain model, you can aggregate existing rasters, perhaps georeferenced in AutoCAD Raster Design, into reusable texture files. Use images such as aerial photography, satellite imagery, scan topographic maps, or even scan development plans as terrain textures. These textures are added to the project as layers and can be blended and layered to provide more information, as seen here with the layering of aerial photography and a topographic base map. Once you have your base, you can extrude simple building footprints prepared in AutoCAD Map 3D, Esri ArcGIS, or MapInfo to create level of detail 1 building models. You can use data held in the attribute tables to define settings such as the building height, the number of floors, or the type of roof which a building would have. These simple extruded building models will also be added to the project as a layer, and you can use the navigation tools or predefined bookmarks to navigate around your model. Individual building models can be selected, and you can change the way they look by applying generic roof types, as in this example, where we've given the building a gabled roof from the drop-down menu on the Properties panel. You can also access and edit the attributes of buildings, either individually or by groups, by using the Attribute button. Use existing 3D vector files to create level of detail 2 buildings, which consist of discrete roof, wall, and floor entities as shown in this model here. Once you've done that, you can start to incorporate georeferenced 3D models from Autodesk 3ds Max or Viz as level of detail 3 data. LOD3 data contains realistic details and bespoke building textures generated from photographs and is really useful for real-world visualization. If, however, you have non-georeferenced 3D models, such as a new bridge design in this example, these can easily be added to your digital city model. Simply browse to the 3D model and then double-click to drop it onto the terrain surface. Then use the model handle to drag and adjust its position, and use the object settings to scale and rotate the model into place. Once the model is correctly positioned, you can save this location file as a position file for future use. Point data representing things such as tree locations or street furniture can also be added to the model. By using data from the attribute table, points can be symbolized using images or 3D models, and features such as the type of tree or the size of the tree can be specified using the import dialog box. By adding vegetation and points of interest to the city model in this way, we allow for a much better understanding and visualization of the urban environment. So once the model is built, there are a number of techniques we can use to make the model more visually compelling. If we head back to our simple level of detail 1 data, we can start to make our data look a little more interesting. Generic building facade images can be applied to the buildings we generated from AutoCAD Map 3D files. By specifying which attribute column contains the facade image and the column dictating how wide that image should be, you can automatically apply generic facades to building models. The The textures of individual buildings can be edited to give a more realistic representation as well. For example, here you can change the texture width from 50 meters to 15 meters to better fit the building model. Another way to enhance the look of your model is to drape the terrain textures onto the building roofs. Here, aerial photography is draped onto the roofs of the building, making the buildings look more realistic. Model visualization can be enhanced by the use of dynamic skies as well. Sky properties such as cloud movement, cloud density, sun elevation and light intensity can be adjusted to simulate different types of light conditions. Here, the sun elevation and azimuth, as well as the sun colors, are changed to give the impression of a twilight sky. LandXplorer gives you many ways of making your model better looking, but another great way of doing this is by using water shading. CityGML files can contain a tag with water shading information, and when this is loaded into the model, it automatically gives the impression of a dynamic body of water. You can see here that the structures, sun and cloud movement are all reflected in the river surface, giving the model a far more intuitive and realistic look. Much of the value of a digital city model lies in the ability to use it for analysis and simulation, as well as for visualization. For example, during the planning and consultation phase of a new development, information which is routinely generated from the planning process can be incorporated from existing data sources. Here, the cadastral footprint of a planned development is imported and shown in red. Then, other analysis output, such as a 100-meter buffer consultation area around the development, can be viewed in the model, providing a more intuitive view of the data available to you. Elements of the model can be changed to enhance visual clarity, such as turning off the aerial photography and using AutoCAD Map 3D to prepare the building models within the consultation area for analysis. LandXplorer allows you to use rules-based actions to thematically analyze these building models. Using the wizard, you can choose which action to perform. In this case, we'll set the building roofs to a certain color, and then build an expression using the drop-down menus, specifying that we want to apply the rule to all buildings which are zoned for residential use. When the Apply button is clicked, all buildings within the consultation area zoned for residential use will be shown with red roofs. You can also import utility data from Autodesk or AutoCAD Map 3D to get a better visual understanding of where the existing utilities lie and where new assets must be installed. Scanned development plans can also be dropped onto the terrain for better understanding of the planning simulation. And you can make the simulation more meaningful by extruding simple building models from footprints created in AutoCAD Map 3D. Once you have your simple block buildings, you can use the individual building properties on the object panel to change things such as the height or the orientation of the building. Here, by changing the height of the building, we can see the impact that a taller building may have on the residential building behind it, without the expense and wasted time of creating physical models. In the same way as before, when you were creating the model, vegetation can be added to the simulation, and you have the ability to combine existing data with models of future possibilities, as we show here by replacing the block model with a more meaningful architectural model. You're able to visualize a potential development in context with data already built or with data which could exist in the future, and explore the impact that it may have on the surrounding environment. For more information about creating your digital city model and about Autodesk LandXplorer, please visit us at www.autodesk.com/LandXplorer.